Hey, hello everyone. How are you doing? This is Tapas, and we are at the day 9 of 40 days of JavaScript. Today, we are going to pick up on another topic, and the topic name is hoisting. And along with that, we are also going to learn about Temporal Dead Zone (TDZ). I told you in the previous session, day 8, that in programming, there will be some jargon, some heavy words. They sound really scary, but once you get into them with fundamentals, with the basic knowledge, they are just like cakewalk. Same thing is going to happen with wasting and the temporal dead zone as well today. But if you are not coming from day 8, if you're jumping into day 9 directly, you might not find it so easy. Believe me, I have broken all the myth. I have made things simplified in the last video with execution context. If you have the idea about execution context and if you have done the task so that you understand what happens in the memory level and internally with JavaScript, when a function gets executed, when a variable gets created, and etc., wasting and TDZ will be just 5 to 10 minutes job for you to understand the concept with examples. Let's get started with wasting first and then TDZ. The term wasting is way more confusing to JavaScript developers, especially the beginner developers, than it should be. The term wasting usually means, the English meaning is like wasting means pulling something up, right? That is called wasting. Now, when you talk about JavaScript wasting, variable wasting, or function wasting, it sounds like that JavaScript is pulling the variable up, JavaScript probably pulling the function up, or function declaration up. It's not actually that. You should not be thinking from those perspectives. Rather, think it more technically. If you understand some portion of the execution context, you already understand wasting. You know how? Let's see with an example. First, with variable wasting. So, guys, look at the code that you're seeing on your screen. There is a console.log in the line number 1, and it is trying to log the value of name, saying name is the name. But hold on, before the line number 1 there is no code. That means name is really nowhere when you are seeing in the line number 1 alone. But look into the line number 2. This is where the name is getting declared with the var. So you have var name over there. Surprisingly, before the name variable got declared in the line number 2, you were already trying to access the value of the variable name in the line number 1. Quite surprising, because in many programming languages you will get this as an error saying that you cannot access a variable without declaring it or before declaring it. But let's see what happened here. When you see the output, you are assigning a value, a string value called Tom, to that variable name which you have declared in the line number 2. And in the last line, you are doing the console.log again to log the value of name. Now, if you look back, line number 1 to line number 4, there are a lot of things happening. Two times we are trying to print the value of the name in the console.log, and line number 2 is when we are actually declaring the variable after we are using it in the line number 1, and in the line number 3 we are doing the assignment. So what is the expected output? Let's see in our DevTools. So the DevTools is showing the output is name is, here it is blank, and then name is Tom. Any of you expected that this will result in an error? If you had expected that this will be resulting in an error, I think you are in the right mindset. But here we are not getting error. Why? Because of something called variable wasting. So what is happening over here? Again, if I look into the code, it looks like that this particular variable name has been wasted over here. Wasted means it's pulled up over here and used over here by JavaScript some way while execution time. That's the reason that this particular name is still valid and it is not giving some kind of error. So that means JavaScript is it like somehow wasting this one up, this particular variable name up automatically, and then doing some kind of magic, gimmicks, black magic, whatever it is, to make sure that when this portion of the code runs or executes, you are not supposed to get any error. Even some beginners think in this way, that when JavaScript execute this code, this line number 2 goes above line number 1 so that the declaration happened before, and then the name will be printed over here, then the following things will execute one by one. If you think in that manner, I think you have a problem. You are going to face a lot of challenges in terms of understanding the basics and the fundamentals, how it works. But if you try to connect it from the execution context point of view, then things will be crystal clear to you. You can answer anything in the world of this sort, even someone trying to confuse you. Now I'm going to take the same code, trying to draw the same execution context thing with our GCE, CP, EP, and all this thing, and see how easily you can map everything that is happening internally in JavaScript. So here you go. This is the same code on the left side, and right side I have printed something called global execution context. Last video we have seen enough. In the global execution context, there will be two phases, we know. One is the creation phase and another is execution phase. What happened in the creation phase? Creation phase, we get the window object on browser, and we also get the this keyword. This getting the window object and getting the this keyword will be immensely useful when you go to the this keyword session in future. But apart from those two things, there is something else happen in the creation phase of global execution context. What? It actually look into what are the variables that declared globally, what are the functions that are declared globally. What is global? Global means outside of any function. Let's create the memory for those variables. Let's create the memory for those functions. If you look into the code right now, in this code, there is no function. We are leaving console.log out for a moment, but there is no function that we have created, but there is a variable that we have created. So in the creation phase of global execution context, this particular variable name will occur, and for this name, JavaScript has to allocate memory. We know from the previous video again that when JavaScript allocate memory for any variable in the creation phase of global execution context, it will also initialize that variable with something called undefined. That's the reason in the CP phase name will be undefined. We are great so far. After that, there is no function, so creation phase is over. Now in the execution phase, JavaScript will start executing things line by line. So in the execution phase, the first line it will hit is console.log name is print the value of name. At this point, what is the value of name? At this point, the value of name is nothing, is undefined, right? Because in the creation phase, the name was initialized with undefined. It was not initialized with any value. That's the reason the first console.log we were seeing something like name is blank on the Chrome DevTools. Got it? Now second line var name. This is a declaration. It has been taken care in the creation phase already. So JavaScript is not bothered about it in its execution phase. It will move on. Coming to the third line, all right, I got name equals to Tom. So I have to put this in my execution phase context. So I have to assign the value Tom to name. That's what it is doing in the execution phase. We know that this is how it happened. And finally, again, the console.log comes in, and now we try to print name is the actual value of name, but this time the name has already got the value of Tom. It is no more undefined. So the log will print name is Tom. That's the reason you are seeing name is undefined, which is blank, and name is Tom. I hope this is clear, and this is what is variable wasting. Look like we are using the variable well before declaring it. How this impossible things is happening in JavaScript is JavaScript is lifting that variable up while execution time? No, don't think in this way. Think from the execution context point of view, and everything is crystal clear to you right now, isn't it? However, don't you think that this could be a problem in programming? I mean, if you start reading a lot of code or reviewing a lot of code where you are seeing that a variable is being used, but you don't know really where it has been declared. Maybe it is declared somewhere at the bottom of your JavaScript file. If you look into some of the legacy code where people used to use a lot of var, if I go around 12 to 15 years back in my career, yes, I have seen things like that variables are declared at the bottom of the file and they are used somewhere at the top of the JavaScript file. But now, would you like to look into the code like that? You won't. And we also discussed that why you should not be using var, before in some of the sessions. This is another reason that why you should not be using var. Because when you use var, this kind of things are bound to happen, which can be error prone, which can introduce some error in your code or some kind of debugging problem in your code. So always go ahead with let or const. Now the same thing if I do with let, what do you think the output will be? Is it going to give the same output? Let's check this out. I get an error. The error says it's a reference error, cannot access name before initialization. Now you are talking, right? Now the program is behaving the way that it is supposed to be, isn't it? You cannot access the variable before its initialization. Then does it mean that for let, or if I use const, wasting is not happening? Does it mean that in the creation phase of global execution context, something wrong is happening? No, it is not. If I go back to the drawing again, and instead of var, if you use let here, the difference will be that in global execution context, creation phase, the variable name will be created, but it won't be initialized with undefined or rather anything. This is probably the biggest difference when a variable is declared with var versus let. In case of var, the memory will be created for that variable and it will be initialized with undefined. In case of let, the variable's memory will be created, but it is not going to be initialized with anything. As it is not going to be initialized with anything, it is something that you can think of as a raw material. It is there, but it is not for any usage until and unless it has a value assigned to it. So until and unless it has a value assigned to it, you cannot really use that particular variable if it was created with let. That's the reason if I run this particular thing again with let, this is how it is going to work. In GCCP, the name will not be undefined. It just got created. That's it. Other than that, it doesn't have any existence anywhere. If it doesn't have any initialization, it doesn't have any value, you cannot use it in your program. Now, when it comes to the execution phase, in the first line itself, console.log name is name, there is no existence of name yet because the name is not been initialized. That's the reason you are getting this error saying that cannot access name before initialization. Initialization is the word. In case of var, it was initialized with undefined. In this case, it is not initialized with undefined. In that matter, not with anything. So why you are not able to use it. Same thing goes with const, but const you have to understand little bit differently. In a sense, if you do something like this, const, in this line itself, it is gone even if you don't have this console.log, isn't it? Because if you declare something with const, you cannot assign any other value to it. Now this one, what is it is going to give the output to you? This is going to say uncaught syntax error, missing initializer in const declaration. You're able to see that the error is little bit different. Before you got the reference error because you were trying to access it without initializing it. But now in the code, I am not trying to access it without initializing it. I have just removed this particular line. With const, when you're creating the variable, you have to make sure that you initialized it here itself. So it will be something like this. You don't have to do this because you cannot do this. You cannot reassign another value. But in this case also, if you had tried to access this before, that means you have initialized it at the line number 2 using const. You have created this variable but tried to access it in the line number 1, you are going to hit with the same error. See now we have uncaught reference error, cannot access name before initialization. You got the point. Now this thing is also related to another term in JavaScript that's called temporal dead zone or TDZ. Keep in mind, not it's a big term, but the meaning is pretty simple. Let me explain to you. Temporal dead zone in JavaScript is something like a area or any block in your source code, JavaScript source code, where you cannot access a variable until it is initialized. Let's think in this way. So TDZ is something, an area where you cannot access a variable until it is initialized. Okay, we take this definition this way. You don't have to remember the definitions, but it is good to know the things in the definition way so that you will recollect it. Now, what will happen if you try to access the variable until it is initialized? So that means what will happen if you're trying to access a variable into TDZ, temporal dead zone? You will get something called a reference error. JavaScript will throw it. We have seen it in 2 examples already. So to give an example, let's take a code block. Now we'll be learning about blocks and all these things in much details in the scope session. But what is block in JavaScript? Whenever you give a pair of these curly braces, you create a block in JavaScript. Inside this block, you can keep your code. We learn like how this block can influence the scope and existence of a variable in the next session. But right now, think about it that I have created a block. Now, as I have created a block, let's imagine that there are some lines of code over here, some lines of code over here. Then over here, you are trying to access console.log of name again, what we have done just now. And then you have again a bunch of code, this line, this line, this line. And over here, you have done let name equals to tapaScript. And then again, you have a bunch of code here, bunch of code here, bunch of code here. Now, my question here is, what is the temporal dead zone inside this block? Can you define this for me? Now, how this thing JavaScript will see? The definition says that this particular block's temporal zone is starting with where the code in the block starts. Remember in this way. Okay. Now this particular block, the code starts from here. Though this code is commented, let's imagine that there is some code. So that means at this line itself, your temporal dead zone has started. That is good. It started over here. But where it ends? It ends when your variable is initialized with a value. That means if at the beginning of the block this temporal dead zone has been started, it is only going to finish, the temporal dead zone is going to finish where it will find that the variable is assigned with a value. That I'm able to find only over here, isn't it? So it means the name variables temporal dead zone, name variables temporal dead zone started here, and as you see it's been initialized here with a proper value. We'll say name variables tdz ends here, correct? So it means that between this to this, the name variables tdz temporal dead zone continues. As the temporal dead zone continues for the name variable from the starting of the block till the point has been initialized, if you try to access this particular name variable in its temporal dead zone, you are going to get what? You are going to get a reference error. This is why I am saying that remembering it through definition is important. Now, if I try to connect this to definition, definition says an area where you cannot access a variable until it is initialized is called TDZ. And if you try to access anything within the TDZ, you will get reference error. Whenever you are in a block for a variable, the temporal dead zone starts from the beginning of the block and it ends when the variable will be assigned a proper value. So in this case, then for name variable, the TDZ started at the beginning of the block and it ended over here at the line number 40 where we have assigned a proper value. So between this to this is a completely TDZ for us, temporal dead zone for us. For what? Be specific for the name variable. If there was another variable, for that variable TDZ would have been different. For example, if there is a variable called say address and console dot log of address, if I do over here, and just in the next line, if I do late address, now can you answer when is the TDZ of address got started and ended? The TDZ of address got started again in the line number 33, beginning of the block, and it's ended where? It's ended where it is assigned over here. You can do something like Bangalore. Now, when you do this, the initialization finished over here. That means it's TDZ start from here to here. So anywhere over here, if you try to access this variable, you are going to get a reference error again. Correct? Because it is in TDZ. Understanding, right? But on the contrary, if I just take this console.log name from here and put it over here, what will happen? Its TDZ started from here, names, and ended over here. So if I'm trying to access name over here, I'll get reference error. But if I'm trying to access name over here, I won't get reference error because in this time, name variables temporal dead zone has been over. It has over here itself. This is the area of the TDZ for name. This is the area of TDZ for address. After that, you can access it without any error. So if I'm not accessing it here, I'm accessing it here, I won't get any error. If I'm accessing it before initialization, I'll get an error. That is the temporal dead zone. I hope it is now dead clear for you. After variable hoisting, after TDZ, let's understand what is function hoisting. So now are you going to talk about hoisting the function up? No, we're again going to understand this from the view of execution context and we'll get the answer. Let's first look into the code. So here we are invoking a function called chase. Clear? Then we have declared the function called chase over here. And the chase function has a console.log and then it invoked a function called caught. And the caught function is over here below. It declared over here. So if you're seeing the example over here, we have invoked this function before we have declared it. We have invoked this function before we have declared it. Correct, na? What will be the output? Can you guess the output? Will it be Tom chase Jerry, then Tom caught Jerry, or it will be Tom caught Jerry, then Tom chases Jerry, or it will be an error? Let's see that. Okay, the output what we see is Tom chases Jerry and then Tom caught Jerry. Tom and Jerry cartoon. So it means this particular function has got invoked and then we have this particular function's invocation. That's why we are seeing Tom chases Jerry first and then Tom caught Jerry. But hold on, shouldn't we get an error here? Just like we have seen with variable hoisting using late and const. Why are we not getting an error? The answer is, of course, hoisting. Hoisting means creating the memory for your function or variable. The phase where you are creating memory for your variable is variable wasting. The phase where you are creating memory for your function and do the basic initialization, what it is called as a function wasting. Okay, this is what is wasting. Nothing is lifted up, programmatically or behind the scene. Hosting is just about allocating memory, doing the initialization of your variables and the functions. In case of variable, we have seen. Let's see it for function from the execution context point of view. Okay, so let us get the answer, like why it is allowed to execute this particular code, why it is not giving an error, and how wasting, which means the memory creation and the initialization phase in the global execution context or the function execution context, helping this particular code to run legitimately. So first we'll go with GEC as usual. In GEC, the phase is CP. What will happen in the CP phase? In the creation phase is trying to create the memory for the variables and the functions. Here, there is no variable. Okay. So there is a function, there is a chase function. So that means in the creation phase, we will create the memory for the chase function. Memory got created. Okay. Then after chase function, we are seeing there is another function called caught. So caught also initialize and memory creation. No more thing to be done on the creation phase. Now it will go to execution phase. What will happen in the execution phase? JavaScript will try to execute the things from the top one by one. So the first line it is seeing is something called chase, but here it is invocation. The moment it sees the invocation, the first thing will happen is chase initialized. Is chase there in the memory? Yes, we have just now initialized chase, isn't it? So it is in the memory. That means we can actually bring it and we can execute it. The moment I can execute it, I will be creating something called a function execution context for chase, isn't it? Now the function execution context, when it gets created, our control will go inside the chase function, where there will be again two phases. One phase is creation phase, another phase is execution phase. In creation phase, no any variable or any other functions are there to define inside it. No, there is no other function, there is nothing else to be defined, there is no variable to be defined, so nothing. But in the execution phase, if I go, I have a console.log to execute. So that means in this phase, the console.log will be executed and it will print Tom chases Jerry, isn't it? This is what it will print. And then it is going to go to the next line of the execution where it is finding something called caught. And here caught is getting executed. So for this, another function execution context will be created for caught. How beautiful these things are, isn't it? Now again there will be a CP, again there will be a EP, and control will go inside this caught function. We'll go inside this caught function. There is no variable, no further function to define, so CP nothing. But for EP, it is having a console.log to execute. So this is going to execute something called Tom caught Jerry. Cool. And then it will come out of caught, it will come out of chase, the execution is over. This is the reason that even if you are invoking a function well before this is declared, you are able to successfully execute it, because in the creation phase itself, the function has been defined and created. And if we try to think it from our heap memory perspective, chase and caught would have got their place in the memory in this place itself, and the address of them must have been mapped like this in the creation phase of the global execution context already, isn't it? So when it comes for the execution phase of the global execution context, it would have already found their existence and would have already found the references in the stack, that like how we have learned in the last video when we did execution context. Everything is mapped with the execution context over here. Don't you feel so? This is the reason even when you invoke a function well before you declare them, it is working. This is what is called wasting, guys. Again, one more last time, anybody ask you the definition of wasting, don't tell JavaScript lift the function up, JavaScript lift the variable up. Those are all stupid definition. The real definition is wasting means the creation phase in the execution context, be it a global execution context or a function execution context, when JavaScript creates the memory of a variable or a function and initialize, and if possible initialize them. Why? Because if it is variable, then we'll call it variable hosting. If it is function, then we'll call function hosting. Why say if possible then initialize it? Because if the variable is with var later point in time, then only the initialization will happen. If it is let or const, the initialization won't happen. It will just create its memory, right? We have learned that. So this is how the entire hoisting picture. Now the last thing, want to know what you think about this code. So I'm just curious, guys, what do you think about this code? What will be the output of this code? Will the output be I am being tested, or you will get an error? Here what is happening, there is a function call happening over here, and look like that we have declared a function below. So it means that, like previous example, the function will be vested and we should be able to see the console.log as I am being tested, isn't it? But let's go to DevTools. Is there a surprise that is waiting for us? We get an error, and the error says type error test is not a function. There is no reference error, nothing, but it says test is not a function. But what I had expected over here, guys, that I had expected that this will be executed, because we have just now learned that you can waste a function, you can call a function before it gets declared. But why it is not working? If you want to find answer of this kind of things, even in the interviews, you will be tested with these kind of things. Again, your way of answering that, guys, will be execution context. That's why I am just telling learn basics. If you think this code with execution context, you have an answer. Why? In the GEC, there is a CP phase. What will happen to the CP phase? CP phase, I see there is an execution, so I won't look into this. But I see this code. What am I going to create the memory for? Am I going to create a memory for a function or a variable? Again, if I look into it, this looks like that I am creating a variable here. I am not creating a function. I am creating a variable called test, and I'm assigning the value of that variable test as a function. Just like var test equals to 10, instead of a primitive number, I am assigning a function over here. That's all I am doing. So it means in creation phase of global execution context, a memory will be created for test and it will be undefined. Correct, na? So that means there is no function that I'm putting into the memory. What I'm doing over here is I am just creating a memory for the variable test. It is a variable declaration. It's not a function declaration. This is a function as an expression, means you are actually declaring a variable and assign the function as a value to that variable. You are not really creating or defining the function. Please remember the difference. So as this is the case, that means I have created a variable now, and I have initialized with this in undefined because it's created with var. Next come the execution phase. In the execution phase, the test will try to be executed, but I have given a parenthesis after that, and test was created as a variable. I cannot give a parenthesis after a variable to execute it. The variable will be without a parenthesis. Only function will be with a parenthesis for its execution, isn't it? So as this test is a variable, that's how I have done it, and the value of the test is undefined. In this line, I'm trying to do undefined and then parenthesis. So if I go over here, and for your satisfaction, if I do undefined and then parenthesis, I'll get undefined, type error undefined is not a function. Exactly same error I'm getting, type error test is not a function, because here test is something like a variable as an undefined. So I am getting this particular execution phase, a big error over here. Nothing is really getting executed. Okay. So I hope that now the function we are when declaring as an expression, you know the difference between a function declaration and what is happening here in terms of variable. So don't fall in the trap of this kind of thing when it is asked in an interview. Always think from the execution context perspective. Draw this thing at the right side, you will get an answer for every execution in JavaScript. I hope it makes a lot of sense to you now. So was it useful to you? Do you think that joining 40 days of JavaScript is a great decision? Let me know if you are finding this journey really useful to your career, so that I get more motivated and bring much solid topic to you, bring things to more fundamentals way to teach JavaScript to you. Don't forget to like and comment on this video. Don't forget to share this video with your friend and coding buddies. And of course, please subscribe, guys. Putting a lot of effort. It feels like a world when you acknowledge that with your subscription. Coming back again with day 10 very soon.